Whenever you get a problem like this, like they tell you about a graph, make sure you label that graph, okay? Label the graph. Sometimes they label it for you, but I would still make a point of pointing an arrow to this and calling it f prime. That's just for yourself. Okay, so here's your graph, the derivative of this function f. On a closed interval from -1 to 5, when I check this out, it goes from -1 to 5. I don't know, like sometimes writing stuff on my graph helps me own it a little bit more. The graph f prime has a horizontal tangent line at x equals 1 and x equals 3. Okay, let's look at that. Here's x equals 1. Is there a horizontal tangent line right here? Yes, there is. And there's also one here at x equals 3. Okay, so it's just telling me stuff about f prime. The function f is twice differentiable. That just means you can take the derivative of it twice. I mean, you get a f double prime with f of 2 equaling 6. Oh, okay, so it gives us a point 26. Is this point 26 on f or f prime? It's on f. So this 26 is not going to be over on this graph because this is f prime graph. Okay, now let's start reading it. A says, find the x-coordinate of each of the points of inflection of the graph of f. F, not f prime. Give a reason for your answer. Okay, so how would we find a point of inflection? Do you guys remember what points of inflection are?
Is that when you draw the line and then you plug in numbers?
Yes, like a sine line graph?
Yeah.
Okay, so this would be the second derivative test. So if you had f double prime and you had this point and this point, let's call this inflection point possible 1 and inflection point possible 2. Remember, inflection points happen where f double prime equals 0. If you have a plus, minus, and then a minus, one of these is an inflection point and one is not. Do you guys know which one would be an inflection point?
The one between the plus and
this one. Because the sign changes. F double prime changes twice. Okay, so what does double prime have to do with our function, the f prime? What does f double prime have to do with f prime? What is f double prime on this graph? If you have f prime and you take the derivative of this, you get f double prime, right? And so what would f prime be to f prime? It'd be the slope. Okay, so look at the slope right here. Where does the slope change signs? It looks like the slope is changing signs at 1 because we're increasing and then we're decreasing. Okay, when we're increasing, the slope is positive. When we're decreasing, the slope is negative. And then we're increasing again, so we change signs at 3. And so before 1, for f double prime, before 1, we have a positive slope. Remember, f double prime is the slope right now. After it, it is negative. And then after 3 is positive. So we have 2 points of inflection. So I'm going to say at x equals 1 and 3, f has a point of inflection and I think because I wrote this stuff, because I wrote f double prime as slope, I think that's enough reason right here, a reason for my answer. Oh wait, no, actually I also have to say because the slope of f prime changes sign. And you can keep it like that. It doesn't have to be a complete sentence. Let's read the next one. At what value of x does f attain its absolute minimum value? Absolute minimum. That's big. That's a big word right there. That should clue you into what you're probably going to do. Okay? On the closed interval from -1 to 5, which we labeled earlier, there's -1 and 5. At what value does x does f attain its absolute maximum value on the closed interval from there to there? Show the analysis that leads to your answers. Okay. So that just means we got to show all our work. All right. So we have B. Okay. If we want to find an absolute max or an absolute min, there's 2 different types of points that we have to test. Okay. We have to test endpoints, and we have to test critical points. I don't know if you remember this. I hope you do. Critical points is where f prime equals 0. That's where you're going to find critical values. Okay, so what are our endpoints for f? -1 and 5. What are our critical points for f? Where is f prime equals 0? Right here. This is f prime, right? So right here at 1 and at 3. No, not 3. Sorry, my bad. Yeah, 4. That's where f prime, which is the y value, is 0. See, it's 0 right there and it's 0 right there. Okay, so we have to test all of these and y prime to find out which one's the max. Okay, now do we know what f is? No, we don't. We do not know what f is. And so, but do we know a way to get f? F would equal the integral of f prime. Now I'm going to say f prime of t, even though we're not using t's. I just have to keep it different than that guy. So f would equal that. Now, so if I want to try to find f, I don't have intervals, which is bad news for me. But if I want to try to find f, I would have to do the antiderivative of this. And when I do the antiderivative of that, I would get just regular f plus c. Okay, so how would you figure this out? I think I'm going down the wrong pathway right here, trying to do this. Instead, let's just try to sketch what f might look like. And that's a hard thing to do because we don't know exactly what it's going to look like, but we can do a rough sketch of what f looks like. So let's do a rough sketch of what f looks like. I want everybody to try right now. I'll give you a minute. I want you to try to just graph what f looks like using the f prime function. So let's sketch a rough graph of what f is. We're going from -1 to 5. All right, go. Okay, now there's two ways you guys can do this. One way is you can graph this point and graph your f based off of that point. But I don't think that's the easiest way to do it. Let's ignore the y-axis right now. So if I start at x equals 1, it doesn't matter where you start because we're not going to mind the x-axis. Okay, we can start right here, we can start down here, it doesn't matter. I'm going to start right here. The reason why I want to start up there is because I know right at -1 the f prime is negative. And so if f prime is below the x-axis, what is f doing right after -1? Or decreasing. Okay, we're going to decrease until we get to 1. So this is 1 right here. What does matter are the x values. When I get to 1, I should be at a slope of 0. So now I'm at a slope of 0. How do I know that? Because f prime got up to the x-axis, we have a slope of 0. And then after that, what happens? What does f start doing again?
Decreasing.
The f starts decreasing because we're below the x-axis. And we're going to decrease until we get to here. What is f doing when we get back to here? It levels out. So we have 4. We're going to decrease until we get to 4, and then we're back to a slope of 0. So you see how we have tangent lines right here that are horizontal? It's because we have a slope of 0. After 4, we're finally above the x-axis. F prime is above the x-axis, and so what is f going to be doing after 4 until we get to 5? It's going to be increasing. So we're going to increase until we get to 5. Now the way I drew it, it looks like we're stopping right here. Okay, yours doesn't have to be perfect though. Okay, this says that at 2 we're at 6. So technically at 2 right here, which would be right here, this would be 6. And so if I had a true x-axis, maybe my x-axis would be right here, and then my y-axis would do this, and this would be 2, and this would be 6 right here. Okay, so now I can see what f is doing. Now I have a good idea of where my minimum value is and where my maximum value is. So where's my maximum value? Clearly,
-1.
it's got to be at -1. -1 is my maximum value. And then what is my minimum value?
4.
It's going to be at 4. Okay? Now some of you guys don't need f. This is graph of f. Some of you guys don't need f in order to analyze or show your analysis. But this is showing your analysis right here. You don't have to use many words now because it's pretty clear what you're thinking. If you don't do this, then you're going to have to use more words to explain what your answer is. And if you guys look at the scoring guide, they use words right there. So if you have this helps show the analysis. And so you can say absolute max is at, notice I said at, because I don't know exactly what the absolute max is. There's no way to figure that out. That's what I was trying to do in the first place. So x is equal to -1, and then absolute min is at x equals 4. Okay, last one, let's do the C. Okay, C says, let G be the function defined by G equals x times f. Okay, so we got a new function here, G. Take time to soak that in. That's the first time we saw G. We see G, so we gotta make sure we understand that. Find the equation for the line tangent to the graph of G at x equals 2. So G is this, and we gotta find the tangent line. Do you guys remember how to find tangent lines?
Yeah.
It's y, and in this case we're gonna have G of, what's our x value? G of 2 equals G prime at 2, and then we have x minus 2. So that would be our tangent line. What is G prime though? I don't have G prime, so I can't find what G prime of 2 is. What's G prime? Let's see. G prime would equal the derivative of this. So what is the derivative of x times f? Well, there's a special rule that we're going to have to use. We have two things multiplying to each other, so we're going to use the product rule. So we're going to go the derivative of x, which is just 1, times f. And then we have plus x times f prime of x. So this is what G prime equals. G prime of x equals f of x plus x f prime of x. Okay, can we find this now? Can we find G prime of x? Or sorry, not G prime of x, G prime of 2. G prime of 2. I have f of 2, and then I have 2 right here, multiplying f prime of 2. Do we have all those values? Do we know what f of 2 is? It's 6. Oh, that's why they gave that to us. Okay, plus, then we have 2 times, do we know what f prime of 2 is? Let's see. Here's my f prime. Where's 2? Oh, it's right there. They gave it to us. It's a -1. So I have a -1 right here. So I have 6 minus 2, which equals 4. So I could plug in a 4 right here. And then, do I know what G of 2 is? G of 2. So let's see. Man, I'm running out of space here. G of 2 would equal 2 times f of 2. Do you guys know where I got that? It defines G right here. So if I plug 2 into this, I have a 2 there and a 2 there. So that's how I got this up here. Do I know what f of 2 is? Yes, it gave it to us right there. So I can write this as 2 times 6, which equals 12. So I got 12 and 4. Looks like I can write what my tangent line function is. We would write y minus 12 equals 4 times x minus 2. And this would be sufficient for an FRQ, but if you're doing multiple choice, you're going to want to get the y alone. So it's going to be y equals 4x minus 8, and I'm going to have to add 12 to that. So I distributed this, and I moved the 12 over. And then after that, I get y equals 4x plus 4. So this is a tangent line function with the y by itself. This is the same thing, tangent line equation. Both answers would be sufficient for an FRQ.